this is worksheet 1 from the chemical calculations packet. In this worksheet, we are going to do a calculation that you actually probably already know how to do for things that are not chemicals. And so we want to apply that knowledge that you already have to the chemical compounds that we're going to talk about. So keep in mind that a percent is calculated by making a fraction of what you are talking about over the whole thing and then multiplying the fraction by 100. That might sound complicated, but if you imagine that we're sitting in a classroom and I ask you to calculate the the percent of girls in the class, right? Most of you are going to know what to do. You're going to count up the total number of students. You're going to count up the number of girls, right? And then you're going to divide the number of girls divided by the total number of students. And then to make it a percent, not a decimal, you're going to multiply by 100, right? So we're going to do the same basic thing now, except with a chemical compound. So if you look at example 1, it asks you, in the entire compound aluminum oxide, Al2O3, what percent of the mass, or the weight of the compound, is coming from oxygen? So basically, we want to put the mass of oxygen on top and the mass of the entire compound, aluminum oxide, on the bottom, divide and multiply by 100. So the first thing we're going to do is we are going to figure out in step 1 here the mass of aluminum oxide. So you have to think about the subscripts, right? You've got 2 aluminums. If you look on the periodic table, each aluminum weighs 26.98, so that gives you the 53.96. And there are 3 oxygens. On the periodic table, each oxygen weighs 16, so that's how you get your 48. Okay? You add the 53.96 and the 48 together, and you get 101.96. In doing this calculation, you have gotten the 2 numbers that you need for step 2. Okay? Step 2 is where we put it all together. We put the mass of the oxygen on top divided by the mass of the whole thing on the bottom. Well, we obviously calculated the mass of the whole thing. That was the whole point of step 1. But in doing that, we also figured out how much the oxygen weighs. Remember, there's 3 of them, so you're not just going to plop 16 on top, because that's how much oxygen weighs. We want to know how much all 3 oxygens together weigh. And you already figured that out. That's the 48, right? So that's going to go up on the top. I divide 48 by 101.96. I multiply by 100, and I get a number that I can round to 47.08%, meaning in the whole compound aluminum oxide, a little less than half of the weight is coming from the oxygen. All right, so that hopefully seemed relatively straightforward, particularly once you get a little bit more practice, right? If we actually go down and look at what you're going to be doing when we're in class, example 1, the one that we just did, that's what you are going to refer to here for problem 1, parts A, B, and C. Okay? But we need to talk about example 2, because when you get to problem 2 down here, it's going to tell you to refer back to example 2. This is a slightly more complicated version of the same problem. The way we make this more complicated, the way you make almost anything more complicated in chemistry, is by considering a polyatomic ion. Those clusters of atoms that stick together and act like they're one thing. So, in our second example, it asks you to calculate the percent of phosphate in calcium phosphate. Right? So phosphate is PO4. So they want to know, of the entire mass of the Ca3PO42, how much of that mass is coming from phosphate. So again, the basic idea is just like it was when we calculated percentage of girls in a classroom, right? We're going to find the weight of the PO4. We're going to put that on top. We're going to find the weight of the entire Ca3PO4 and put that on the bottom. Then we multiply by 100. You just have to be really careful to consider all of the subscripts that are happening when we throw a polyatomic ion into the mix. All right? The most efficient way to do this, so you don't redo calculations and waste your time, is calculate the mass of the phosphate, the PO4, first. So that's going to be our step 1. Okay, so in PO4, you've got 1 phosphate, it weighs 30.97. You've got 4 oxygens, which each weigh 16. So you add all these numbers together, and you get 94.97, right? Now, we're going to have to calculate at some point in the future the fact that we don't just have 1 PO4, we have 2 PO4s. Okay, so this 94.97, when we go to put the mass of the phosphate in the top of our fraction in the following steps, we're going to have to multiply that 94.97 by 2. Okay? All right, so hold that thought. On to the second step. We still need to find the mass of the entire thing, right? Oh, by the way, this MM here stands for molar mass. So, I've got 3 calciums that each weigh 40.08. I've got 2 phosphates. Now, we know that each phosphate weighs 94.97, right? So, like I said before, I'm going to multiply that by 2 because there's 2 of them. Okay, and then I'm going to add those numbers together and get 310.18. Okay, so that's another number that we're going to use in the next step. Okay, third step, putting it all together, actually calculating a percent. Again, we know that 1 PO4 weighs 94.97, right? But we know that there's actually 2 PO4s. So we take that 94.97 and multiply it by 2. Now, if you're smart, you'll look down here and see that you've already done that. It's 189.94, right? Otherwise, you redo the calculation. Waste a little time, but fine. Okay, so we put that on the top, and then on the bottom, we put the mass of the entire thing, the Ca3PO4. We divide, we multiply by 100, and we round our answer to 61.24% PO4. Okay? So, that's the basic idea of what you're going to be doing when you come to class. Example 1 is how you do parts A, B, and C of question 1. And example 2 is how you do parts A, B, C, and D of problem 2. So, we will practice that more when we get to class.